Hello, and welcome to the Ocean News Podcast, an audio series taking you through the biggest stories and the breaking news from the Oceanographic newsroom. I am Rob Hutchins, news editor here at Oceanographic magazine, and in this episode, I'll be leading us on a deeper dive into just one story from today's biggest headlines. Now, today, we're revisiting the issue of microplastics, a problem so pervasive that scientists have now been left shocked at the concentration levels discovered in the vital organs of both male and female loggerhead sea turtles. Microplastics have now been found in all of their vital organs, including their heart, kidney, and liver, but with the highest levels found in the male reproductive system. It's a discovery that has now sparked major concern among scientists over the future survival of the species, particularly one as vulnerable as the loggerhead, for which the reproductive cycle is already such a delicate dance with the ocean environment. Studying the bodies of 10 stranded loggerhead sea turtles that had each suffered drowning and exhaustion when they were accidentally caught up in commercial fishing nets, researchers from the University of Manchester here in the UK believe these latest findings could spell disaster for a species already suffering a stark decline in numbers. So let's look into the story here. Already we know that sea turtles, loggerheads in particular, are routinely in contact with and ingesting ocean plastic pollution. More often than not, they are mistaking plastic bags for jellyfish and ingesting this pollution accidentally. So, while scientists were fully prepared to find some level of plastic within the bodies of these 10 unfortunate turtles, they perhaps weren't quite prepared to see the extent of the pervasiveness of microplastics and just how far spread throughout each turtle's body the plastic particles had become. While these microplastics were indeed found in all vital organs of both male and female loggerhead sea turtles, as well as within their skeletal muscle, subcutaneous fat, stomach, and intestines, the highest concentrations by far were found in the male reproductive system. The study has been published in the journal Marine Environmental Research and is the first study to show that microplastics from the gut of the sea turtle can translocate, opening up the possibility of different organs, especially the reproductive system, being directly affected. To learn more about the study and the crisis of microplastics being faced by the loggerhead sea turtle, we caught up with the study's lead author, Leah Costello, a PhD researcher from the University of Manchester. So, Leah, thank you so much for taking the time to chat with us. Just to kick us off then, can you talk us through your study and the sort of the height of the crisis that sea turtles are suffering right now when it comes to ocean plastics and plastic pollution?
Okay, so plastic ingestion in sea turtles is pretty well investigated at this point, and we've started to see quite a lot of papers coming out about the wide-reaching scale at which we're finding microplastics in almost every kind of organism environment that we look in. So I wanted to kind of use this as a starting point in sea turtle research to have a little look at the kind of scale of the impact of microplastics. There's obviously loads of information about sea turtles eating larger plastic items, finding plastics in their guts, but not much else has really been investigated. So that was what this project was. We wanted to provide a starting point to give a solid basis for more physiological research into the kind of longer term impacts that we might see from microplastic accumulation. But in order to do that, we needed to see if there were plastics in the tissues. So so we analysed all of the major organs from the loggerhead turtles, and quite shockingly found plastics in almost every single sample that I looked at. So it means that this is definitely a kind of avenue of research that needs to be sort of looked at a little bit more. We need to kind of understand what the actual physiological implications of the plastic presence are.
But you must have had an inclination that there was going to be microplastics present, but maybe just not of this sort of
Yeah, I kind of hypothesized that we would see like really high levels of plastic in fat tissue, or maybe even in skeletal muscle tissue. I was sort of expecting that there would be some kind of like biological mechanism to sort of sequester these plastics into stored fat. Um, but I really wasn't expecting to find plastic in every single major organ. So yeah, it was a pretty shocking result.
Yeah, and why would it have been the case that it is so sort of pervasive? Why is it found in all these different organs? There was some technical terms that you used in the study.
So the main kind of avenue, the main kind of school of thought at the moment is thinking that microplastics translocate, which means that they can pass from one area to another. And we think that they're translocating into the circulatory system. So this means that when microplastics are in the gut, they can quite easily pass across the intestinal barrier if they're of a specific size. So once microplastics cross the intestinal barrier, they enter the circulatory system, so the bloodstream. And once they're in the circulatory system, they circulate around the entire systemic circuit. So the blood passes through the heart and circulates through all of the other major organs. And during this time, we think that plastics can become lodged in the tissues and become embedded, especially in tissues where there are quite narrow capillary networks. So where the blood vessels are really narrow, we think that microplastics are probably, that is the reason that we see quite high accumulation in organs such as the reproductive organs and the heart, because so much blood is circulating through the heart, and the reproductive organs have really small capillary networks. So, yeah.
Yeah, it's really sad. It's quite upsetting because obviously with sea studies, and like you mentioned, like we see it everywhere now. Like it's ubiquitous, isn't it? Microplastics everywhere. I think in the marine space, one of the most shocking ones we saw was traces of microplastics in dolphin breath and
Yeah.
food like this. But I guess given the nature of this one and the species itself being a vulnerable species, and the process of reproduction being so sort of like hairpin, like such a fine sort of balance, isn't it? Like temperature wise and all these things that impact like reproductive rates. What are some of the big concerns then over this finding for like, the reproductive cycle for sea turtles?
Yeah.
The implications there?
Well, I think the main kind of concern is that microplastics themselves can act as vectors for introducing other toxic compounds in the environment. So kind of persistent organic pollutants, heavy metals, they can sort of hitchhike on the microplastics and be brought into the system. And also the chemicals that are used to make plastics are shown to have like quite bad impacts on the endocrine system. So when we think about impacts on the endocrine system, we can see things such as impacts on growth, impacts on development. And there's also been studies that show that microplastics can be vertically transferred from the mother or from the maternal environment into the offspring. And that can lead to impacts on locomotive performance, development, reproductive development, and also reproductive success as well. So we haven't actually directly looked at the implications of high plastic in the reproductive organs, but we think that it could lead to reproductive toxicity. So there's been another study fairly recently that looked at humans and dogs, and they found microplastics in almost every single testicle sample that they looked at. There hasn't really been any sort of like supposings as to why we might see plastics in the reproductive organs, and particularly in the males. It could be something to do with the fact that this is like potentially a good way for plastics to be ejected from the body, but there isn't actually any research on that. So I think that is the next step in this research, and that is actually what my next project is looking at now, is looking at the presence of microplastics in unsuccessful sea turtle eggs. But yeah, like we don't 100% know what the the reproductive impacts are, but this is why it's really good to start looking at it, because sea turtles are already under so many other pressures from human activity, and also from the changing environment as well.
So what would you like to see the impact of this study be, and then further studies? What impact would you like these to make in terms of our approach to conservation, or our approach to infrastructure, or waste management and pollution and all these?
I think in terms of sea turtle biology and conservation, this is kind of like a call to research. This is, a finding that in even seemingly healthy individuals, we could see that they're actually under really high levels of physiological stress. We could see that the extent of the physiological stress starts to increase if we don't change the way that we are dealing with our plastic waste. So I think it's kind of multifaceted, really. Like, on one side, for sea turtle conservation, we hope that this will kind of alert sea turtle conservationists and people that are working in rehabilitation centres that actually the scale of the problem might not be as visible as we previously thought. We see quite obvious impacts like intestinal blockages, entanglement, and drowning. Those are the really obvious things to see, but actually, like, there could be a lot going on under the surface. And seemingly healthy individuals could be quite physiologically compromised, and that could really be impactful for populations that are already struggling to recover, or populations that have been deemed vulnerable. In terms of kind of the impacts on policy and things like that, I think that by building up this irrefutable catalogue of evidence that we have that microplastics are now everywhere, we are hopefully going to be pushing more into development and rolling out sustainable plastics. There's amazing technologies available now which have produced disposable plastics. That I saw recently, a plastic polymer has been made that dissolves in seawater within 24 hours. Like, we have to just be making a shift towards these kind of things. Like, it's really imperative. We can't kind of rest on our laurels of, oh, plastic is really important. Like, yeah, it is, but there are sustainable alternatives that can really help us to reduce the impact that we're having on all ecosystems.
Well, thank you so much for talking us through this study and all your insight and expertise here, and best of luck with the upcoming study. It'd be great to to stay in touch and be kept up to date with those developments. So yes.
Yeah, 100%. Well, I'll keep you posted on the next
Yeah.
phase of the project. But yeah, so this one should be really interesting as well. I'm quite excited. We're looking at directly at maternal transfer. So so we should be able to kind of like add a bit more information as to whether microplastics are entering the eggs before they're even laid, and whether that's during fertilization or egg development. So yeah, so hopefully adding another piece to the puzzle.
The study, titled Microplastics Accumulate in All Major Organs of the Mediterranean Loggerhead Sea Turtle, has been published in the journal Marine Environmental Research. If you'd like to learn more about this story, or other stories on the loggerhead sea turtles and the microplastic pollution crisis, head to the Oceanographic Newsroom. This has been the Ocean News Podcast. I've been Rob Hutchins. Thank you for listening.